Let's study basic electricity this week in mechanic diesel. Electricity is one of today's most useful source of energy. Electricity in motion is called electric current, whereas the electricity that does not move is called static electricity. Basically, an atom contains three types of subatomic particles that are of relevance to electricity: electron, protons, and neutrons. Ohm's law, EMF. The voltage developed by a source such as a generator is called as electromotive force, EMF. A is voltage, B is current, C is resistance. Have a look on a video for briefing of Ohm's law.
According to Ohm's law, with more voltage, the current flow will be more, and with more resistance, the current flow will be less after passing the resistor. Now, to understand Ohm's law better, first we should know what exactly is current, voltage, and resistance.
Current is actually the flow of electrons in the circuit. The material with which the circuit is made is called a conductor. The unit of current is ampere. It is denoted by letter I. Current refers to the quantity or volume of electrical flow. The current I in ampere is equal to voltage V in volts divided by the resistance R in ohms. I is equal to V by R. Look at the water flowing out of the pipe here. The water is flowing at the constant rate continuously. So similar to the flowing water here, the current flows in the circuit with certain pressure, that is voltage. Imagine a boy is throwing a ball. The distance and the speed of the ball is depend upon the force applied to the ball. So the speed and the distance is directly proportional to the force. In the same way, electron flow is caused by a voltage. More voltage will cause more electron flow, and less voltage will cause less electron flow. So, current is directly proportional to the voltage. Now, let us understand what voltage is. Voltage, also known as EMF, electromotive force. It is the force which is required for the movement of electron in a conductor. The unit of voltage is volt and it is denoted by letter V. It is the push or pressure behind current flow through a circuit. The voltage V in volts is equal to the current I in ampere times the resistance R in ohms. V is equal to I multiplied by R. Here, as we can see, the water is flowing as it is because of a pressure applied to it. Now, if we consider water as current, then pressure applied to it is the voltage. The electron in the outermost shell, that is, the valency electron, becomes a free electron when it is removed from the valency shell to pass through the circuit by applying a force. That force is called voltage or EMF. Now, let us understand resistance. Resistance is the property of a conductor that oppose the flow of electrons or current in the circuit. The unit of resistance is ohm and is denoted by letter R. In simple terms, resistance is the obstacle in the flow of the current. The resistance R in ohms is equal to voltage V in volts divided by the current I in amps. R is equal to I divided by V. In the image below, we can see water not flowing properly but dripping drop by drop from the tap. Imagining water as current, Resistance is the hurdle here that is not allowing the water to flow properly. In this example, you could see a river containing a rock. This rock will slow down or oppose the flow of water in the river. Same way, resistance will behave like a rock in the conductor. It will oppose the flow of electrons in the conductor. In some materials, the resistance will be high, so the current will be low. More resistance will cause lesser current flow, and lesser resistance will cause more current flow.
Therefore, current is inversely proportional to resistance. Altogether, current is voltage by resistance. I is equal to V by R. Finally, the Ohm's law states that constant temperature current is directly proportional to voltage and inversely proportional to resistance. From this Ohm's law triangle, voltage can be applied by using the formula V is equal to I into R, and current can be applied by using the formula I is equal to V upon R. Resistance can be applied by using the formula R is equal to V upon I. Hope you all understand the concept of Ohm's law.
Conductors. A conductor is a material that has many free electrons, permitting electrons to move through it easily. Some common good conductors are copper, aluminium, zinc, and lead. Insulators. An insulator is a material that has few, if any, free electrons and resists the flow of electrons. Some common insulators are air, glass, rubber, plastic, and paper. Shielding is the protective device layer over the insulated cable. Uses: it acts as earth or ground for the electrical appliances. It protects the cables from moisture entering as well as flexible. There are three basic types of meters used to test the electric circuit and accessories. Ammeter. The ammeter is fitted on the vehicle panel, board, or dashboard. Voltmeter. A voltmeter is used to measure electrical voltage. Ohm meter. An ohm meter is also known as resistance meter. It has its own built-in power source. Uses of ammeter. An ammeter is used to measure the amount of current flowing in the circuit. This is connected in series with the load. It is used to indicate the rate at which the battery is being charged or discharged. Uses of a voltmeter. To measure the voltage at any point of circuit, to measure the voltage drop in the circuit, to check the condition of the battery. Uses of ohm meter: to measure the resistance of any conductor, to measure the resistance of any load, to check the continuity of the field coils. Multimeter. A multimeter is an instrument in which the functions of an ammeter, voltmeter, and ohm meter are incorporated for measurement of current, voltage, and resistance respectively. There are two major types of multimeters: ordinary multimeters having passive components, electronic multimeters having active and passive components. Parts of a multimeter. A standard multimeter consists of these main parts and control as shown in figure. Resistors. A resistor is manufactured with a specific value of ohms resistance. The purpose using a resistor in circuit is either to limit the current to specific value or to provide desired voltage drop. The power rating of resistors may be from 0.1 W to 100 of watts. Law of resistance. The resistance R offered by a conductor depends on the following factors. The resistance of the conductor varies directly with its length. The resistance of conductor is inversely proportional to its cross-sectional area. The resistance of the conductor depends upon the material with which it is made of. It also depends on the temperature of the conductor. Ignoring the last factor for the time being, we can say that R is equal to PL oblique A. Lesson learned. Thank you for listening.